Good morning, everybody. So thank you for your kind introduction, Graham. So I'm Alan Norbury. I'm Siemens Industrial CTO. So my office is just down the road at Manchester. If you came in from the M56, you might have seen the big white building on the right. Looks like a big water tower. That's Siemens. So Siemens in the UK, we have, globally we have 9 divisions. 2 of those divisions I work for. One is called Digital Factory, the other one's called Process Industries and Drives. So in the UK, Siemens employ 15,000 people, and we have 14 factories at the last count. So we're one of the very few companies in the UK that both provide technology and we also manufacture technology in the UK. And that's from traffic control systems through to MRI scanners, to subsea connectors, and the very latest factory that we've just built, that was just opened last year, was Siemens in Hull, where we manufacture wind turbine blades. And the vision there is to employ over 1,000 people in Hull. So hence we've got 1,000 employees in the UK. So you'll probably see this slide many times over yesterday and today. I'm not going to go to a lot of detail of Industry 4. However, the point that I'd like to raise is that it's all about the technologies on the right. It's all about virtualization, so accelerating the innovation cycle and using it for modeling processes, for example. It's all to do with digital twin. So this is where we have a physical model and a virtual model. And I'll go into a bit more detail. Cyber physical systems, where we close the loop on the digital twin, where we gather data from the manufacturing process and feed it back into the virtual world. Big data you've probably heard of many times. Big data doesn't mean anything unless you do something with it. So smart algorithms are becoming quite important in terms of managing that data and turning it into something useful. Internet of Things, where we have smart sensors that can have accessibility onto the internet. Advanced robotics, and I don't just mean big robots in cages, but also small robots, what we call cobotics, where humans are working alongside robots. And we've just acquired our first cobot down in Congleton in our factory where we manufacture variable speed drives. And the challenge there is, how do you apply a cobot without the relevant standards? So that's something we're working with the health and safety executive around. Cloud technology, accessibility of data at our fingertips. 3D printing or additive manufacturing, as it tends to be referred to in industry, where we can manufacture different shapes, single piece parts from powders and laser smelting. And of course, we've got to do that in a secure way. So throughout all of this, you'll see there's a thread, and it's all to do with digitalization. So digitalisation changes all areas of our lives. It changes the way we stay informed, it changes the way that we travel, and it changes the way we buy things. But it also changes the way we manufacture products. And digitalisation is putting increasing pressures on manufacturers, but at the same time, it's opening up new business models. So here's a few new business models that you may recognise. So today, if you want to read something, rather than picking up a book or going to a library, you can download it and you can stream it and you can put it onto your iPad or your mobile phone. And same with records and music. So in the past, you'd go to a shop and you'd buy a vinyl record, whereas nowadays you can stream music onto your phones or your iPads. And again, if you wanted to find information, like you wanted a builder or somebody to help you put something together at home, in the past you'd go to the Yellow Pages, whereas today you can go to online and you can look at apps and they'll give you a local company that can do work for you. And things like Uber as well is changing the way that we travel. I've had some good and bad experiences with Uber, but I'm a converter now, especially when I travel around London. But the point I'm trying to make there is these companies that are mastering data are becoming very, very successful businesses. So what are the drivers behind Industry 4? Well, it's down to consumers like you and I, and how manufacturers address the challenges of consumers. So a good example I've got a brand new phone. It's only 2 weeks old, believe it or not, and it's called a Samsung S7. And guess what? They've just brought out a Samsung S8. So how do you address the challenges of consumers that want the latest technology as soon as the last technology has just been released? So how do we accelerate those innovation cycles to bring new products to the market a lot quicker? Flexibility. So what I'm referring to there is customization. There's a demand from consumers for customized products. So if you look at the automotive industry, if you buy a brand new car, you expect to specify the colour, the shape, the engine, the trim. But then if you look at other industries like the food and beverage industries, they're moving towards customized products to suit everybody's individual tastes. So for example, there's a company in Germany called My Muesli, and you can actually configure what muesli or what ingredients you want in your muesli online, and they'll manufacture it and deliver it to your door to your specific taste. So this challenge of customization is going to cover all sectors, even pharmaceuticals, where they're working towards personal medication. So if you go to the doctors with an ailment, no matter what shape, weight, gender you are, the doctor will give you the same medication as they would somebody else with the same ailment. Whereas in the future, what they will do is they'll develop medication to suit your individual needs. And that will start to take place over the next 30 years. So customization covers all sectors. Quality, so now there's an expectation for products to last a lot longer, to have a higher quality, longer service intervals, for example. And efficiency, so better use of resource. So I don't just mean energy efficiency, but also machines. Can we make better use of machines so they're flexible so they can make more than one product? So those are the drivers behind Industry 4. And as I said before, it covers all sectors, whether it be process sector, whether it's discrete sector, makes no difference. Industry 4.0 will affect all those sectors. And the glue in the middle of all of this is communications, it's security, and it's all about services as well, gathering data and making use of data. So if you look at the life cycle of manufacturing, what you'll find with most companies, throughout the life cycle of their manufacturing processes, they'll have lots of disparate sets of data, and that's quite normal. And the utopia is to have a single set of data that is like a master template for your data throughout your whole factory. And then above that, we need accessibility of data and converting that into something what I call business data, converting big data into business data. And this is where you'll start to see a lot of apps, similar to the apps that you get on your phone, but for industry, which will convert big data into business data. Then the next level that we need to look at is something called a digital twin. And again, that covers the whole life cycle of manufacturing. So you think, well, why do we need a digital twin? That's more effort. Well, the reason we might want a digital twin is we can do all our engineering in the virtual world. So if you have a manufacturing process that's making products, you don't want to impact your manufacturing process with trying new things out. But you can do that in the virtual world. So you can do your engineering in the virtual world, without impacting on production. And also you can use it to reduce the number of physical prototypes. So you go from, for example, in our factory in Congleton, 3 years ago, we had 9 physical prototypes for some of our piece parts for our drives. Now we're down to 3 physical prototypes because the rest are done in the virtual world. In other words, we can bring our products to the market a lot quicker than we could do before. So I mentioned cyber-physical systems, and this is where the virtual world meets the real world, but then we feed back manufacturing data. So the example I use is a bottling line. So if you can imagine you have a bottling line. On a bottling line, you'll have a filling machine, you'll have a capping machine, you'll have a labelling machine. If you broke down those manufacturing processes into individual production units, in a perfect world, you would virtualize everything within that production unit. And that will be all the things you see on the right-hand side in the future. Some of this you can do today, some you'll be doing in the future. So that includes software, mechanics, which you can do today, safety, maintenance. All of that will be put into the virtual world, and all the engineering will be done in the virtual world. So if you make a mistake, it doesn't really matter. You can modify it, you can change it a lot quicker in the virtual world than you can in the physical world. And once you've gone through your virtual prototyping and you're happy with your manufacturing process, then you migrate that across to the actual physical world, such as you can see on the left-hand side. And then we start to manufacture product. So as we go through the life cycle of manufacturing product, our digital footprint gets bigger and bigger and bigger. The bigger that digital footprint becomes, the more we can do with it. And then we can feed it back into the virtual world. So let's say we're making product A, and now our digital footprint gets bigger and bigger and bigger. We can feed that data back into the virtual world and see if we can actually manufacture product B in the virtual world. And once you're happy with that, migrate the data across to the physical world and start making product B. Hence, we get closer and closer to this utopia of mass customization. The other thing that we need to be aware of is that with most manufacturers, what you'll find, no matter who they are, Siemens, for example, most of our manufacturing is in the supply chain. So what is the point of doing all this great innovation using virtual reality in the manufacturing process if you don't include your supply chain? So what I've done here, I've tried to show mass customization feeding all the way through to the supply chain. Because one of the challenges of mass customization is stock control. If you think that every product could be completely different, that could potentially mean massive stock levels. Now, if you feed that all the way through in terms of communication down to your supply chain, you could potentially, in the long term, manufacture to order such that you reduce your stock levels. And if your supply chain can actually mass customize, again, they will link their data between the actual OEM into the supply chain to manufacture products as and when required. So this is where the cloud will fit in. And one of the visions behind Industry 4.0 was that the raw material will hold all its data for its manufacturing process, for its logistics, and what part it plays in the final product. So things like RFID technology. The reason this will be quite useful is because you can read and write to it, you don't need line of sight. So you can modify the RFID tag on the raw material as it's going through its manufacturing process, so it knows what's happened to it. The product can also tell the machine what to do to it, whereas traditionally the machine defines what to do to the product. Hence, every product could potentially be different. Then it can organise its own logistics and then be delivered to the manufacturer just at the right time to go onto the final piece part. So it's a bit of a long-term utopia, but this is the sort of vision of Industry 4.0 and the direction it will be taking us in. So one of the other challenges is how do we manage big data? How do we convert that big data into something useful? So what happens on the shop floor, all these Internet of Things devices will be giving off lots and lots of data. And what you'll find in the future, more and more companies will be developing apps to make use of that data. So we have that business data at our fingertips. And the link between the two is something called MindSphere. So this is an open platform. So at the bottom level, we'll have open interfaces like OPC UA. At the top end, the apps will be an open architecture as well. So it's not just about Siemens, but any company could develop an app. And the link between the two will be MindSphere to give the accessibility of this data anywhere in the world securely. So in summary, there's 3 things to consider if you're looking towards becoming a digital factory. The first thing is the infrastructure. So what I say to a lot of customers I deal with is, do your machines have the capability of becoming part of the Internet of the Things? In other words, do they have an Ethernet port built into them or a wireless access port? So maybe that'd be the first thing to invest in or consider. Second thing is virtualization. So can you virtualize either your factory, so you can change the layout of the factory? Can you virtualize your machines, so you can modify or even train people in the virtual world? Can you virtualize your products that you're manufacturing, so you can bring products to the market a lot quicker than you could do before? And then last but not least is skills. And in the future, we'll need a combination of skills. We'll still need those traditional engineering skills that have been taught in colleges and schools for many, many years. But we'll also need the skills to be able to engineer in the virtual world. We'll need those creativity skills, the sort of skills that apply to the gaming industry. So we need a combination of skills to be able to engineer in the virtual world. Why do we need to do this? Well, potentially batch sizes of one, where every product could be different. It means that we could work towards this vision of zero physical prototyping, where the first prototype that you produce, first physical prototype, is your final product. And also highly flexible manufacturing, such that your machines can make more than one product. So PwC did a survey recently on Industry 4.0, and the outcome was that digitalization, average levels of digitalization, will increase from 33% to 72% in the next 5 years. And globally, companies will invest 5% of their revenues on digitalization. Now that equates to $907 billion per year on digitalization. And in the UK, digitalization is anticipated to add an additional £91.6 billion to the UK economy by 2035. So if you think about the dreaded word Brexit, and to remain globally competitive, there's three things we need to consider. We need to embrace digitalization, we need to invest in digitalization, and we also need to consider that we should be leading Industry 4.0 in the same way that we did the first industrial revolution. Thank you.